Finally, we'll look at options on futures contracts. And the forward price is the same as the futures price. We're going to just assume that. We'll ignore any potential optionality in the futures contract. We then have nodes of U. Because the forward and the futures price are the same, this is the same formula we had earlier, which is U is equal to the forward price times e to the sigma square root of h. And the forward price is just the futures price, so all we get is the action of the volatility terms. Now, what is our replicating portfolio? Well, this is an option on a futures contract. So the replicating portfolio is going to be made up of delta futures and B dollars in T-bills. Notice that the cost is B. We can enter delta futures contracts for free. There may be a margin account associated with that, but the margin account is our deposit account. It's not part of the cost. We will enter into delta futures contracts and B dollars of T-bills. The total cost of that option will be that portfolio will then be just the B dollars needed for the T-bills. Now, what happens to this position over the passage from T to T plus H? Well, predictably, the T-bills just grow by the risk-free rate. But notice what happens to the futures contract. The value of the futures contract goes from F to U times F. But the profit we make on the futures contract is just the difference. In other words, unlike when we're modeling stock, where at the end of the period our portfolio reflects the stock price at that time, here it's only the change in the futures value that we earn by entering into a futures contract. That's the margin account adjustment that I talked about earlier. You enter into a futures contract, at the end of the period the future's worth U times F. In your margin account you have UF minus F, whatever that is, positive or negative. So in solving these equations then for delta and B, we get these equations. And here, delta tells us how many futures contracts. I made that point earlier. And then B is the value of the option because the delta futures contracts is free. For the futures contract, once we develop the price using this value of delta and B, this is now, of course, the cost of the option. We can do some algebra on this, and we can see, in fact, even as it stands, this is in the form of, here's a P star, and then this term is the 1 minus P star. So the B is the cost of the option, has the standard form we've been seeing for the cost of an option. It's actually the T-bill position, but it's also the cost of the option. It's the present value of the expected payoffs. And the P star is this term, which we see directly from the formula for B.